Hello, everyone. Welcome to our TestWheel webinar, where we'll be covering accelerating testing for defense and public sector systems while with secure automation to produce a reduction in testing time and save taxpayer dollars. TestWheel is actively working to assist several systems across the federal government, including the Air Force, the DoD, and the National Archives, to name a few. And with that, let's segue into our presentation. I am Delaver, a technical analyst here with TestWheel, and I'll be the one going on and presenting for you today. Let's talk about the current state of testing in modern software development. A lot of teams are still stuck in a cycle of manual testing or relying on fragile script-based automation. And while those methods can get the job done to a certain extent, they come with a lot of baggage. Manual testing is slow, repetitive, and prone to human error. Script-based automation can help, but it often requires constant upkeep and one small change in the application and suddenly the test scripts break. That kind of fragility leads to lack of trust in the results and worse, can create blind spots. So what are some of the consequences of this? Bugs slipping through the cracks, sometimes all the way into production. This is especially risky in high security environments where reliability isn't just nice to have, it's critical. And it's not just an inconvenience, it's costly. So according to IBM, fixing a defect after a release can cost up to 100 times more than if that same issue had been caught during the design phase. So the question is, why are we still relying on outdated methods in such a fast-moving, high-stake world? Software flaws are still one of the leading causes of security breaches, project delays, cost overruns, and failed audits. And despite all the progress we've made in development tools and processes, testing often remains a weak point. The reality is over 80% of bugs that end up in production could have been caught much earlier if only thorough and automated testing had been in place. And it's not just a technical issue, it's an economic one. According to NIST, software bugs cost the US economy nearly $60 billion a year. And what's more surprising is that over half of that cost could be avoided with better testing practices. But in today's world, especially in high security or regulated industries, efficient integrated testing isn't just a best practice anymore, it's a business critical need. So the bottom line is, the earlier you find and fix bugs, the cheaper and safer it is. Waiting until after release doesn't just increase costs, it increases your risk. And in some environments, that risk just isn't acceptable. So testing in federal environments comes with its own set of challenges, one that commercial teams may not have to face. So first off, manual testing bottlenecks. Long test cycles slow everything down, delaying releases and adding unnecessary strain to already stretched teams. Then there's the compliance risk from human error. It's easy to miss steps, forget to document something, or lose track of changes, and that's exactly what can trigger audit failures. Security barriers are another big one. Integrating automated tools inside air-gapped networks or with CAC and single sign-on systems, not that straightforward. And finally, procurement and policy hurdles. Just getting a new tool approved can take months thanks to complex licensing reviews and regulatory red tape. And that's why any testing solution in these environments has to be secure, efficient, and easy to integrate without adding risk or friction. When bugs slip through until late in the development cycle, the impact isn't just technical, it's financial, operational, and sometimes even reputational. Like I mentioned earlier, the later you find a defect, the more expensive it becomes to fix, and that can seriously derail your schedule and budget. Even worse, some of those late stage issues turn out to be security vulnerabilities. And when those go live, they can lead to breaches with wide-reaching consequences, especially in the public sector. The truth is, smarter test automation doesn't just improve quality, it saves money. Public sector systems alone could save billions just by catching these issues earlier in the development cycle. So. This right here is a little graphic to kind of showcase where the cost is the highest for in terms of bug fixing. And you'll notice that the earlier on in the development life cycle that a bug is detected, the less it costs to fix. And the later we identify an issue, the more it costs to fix. So why TestWheel? One of the biggest hurdles in federal and defense environments is security identity integration, and TestWheel handles this natively. We support CAC authentication and single sign-on right out of the box, making it easier to plug into existing access control systems. We also give teams the option to enable automated login using soft certificates, so you don't have to rely on a physical CAC token for every single test run. And that means fewer manual steps, fewer test interruptions, and smoother automation, all while staying compliant with federal access requirements. So TestWheel is designed to operate where traditional tools fall short. It's deployable in air-gapped or isolated networks or network environments. It requires minimal internet connectivity for execution and reporting and aligns with strict IT governance, including auditability and role-based access controls, and test automation that functions securely, reliably behind the firewall and not just in the cloud. TestWheel is also officially listed in the DoD's Iron Bank. The Iron Bank is the U.S. Department of Defense's secure repository of trusted software tools, which means TestWheel has been vetted and approved and meets the DoD's highest standards for security and compliance. TestWheel is pre-cleared for use in Department of Defense environments. It undergoes rigorous security scanning and container hardening. It's compliant with STIG guidelines and other DoD cybersecurity requirements. And this listing reduces procurement friction and significantly accelerates ATO processes. Looking at our security specifications, you can see TestWheel is a platform built with defense and government systems in mind, with its security-first architecture. TestWheel's secure architecture offers things like robust data masking, continuous vulnerability scanning, encryptions, and several other points which allow TestWheel to be Iron Bank listed. We've proven with our work on several Air Force, DoD, and other public sector projects that TestWheel offers a secure solution. So why does it matter? With TestWheel, agencies can detect software defects earlier in the life cycle, automate securely using CAC and single sign-on in controlled networks, confidently deploy in classified or offline environments, and leverage Iron Bank certification for faster adoption and compliance. All right. And with that, we'll go ahead and jump into our demonstration for today. All right. So in this demo, I'm going to break down the TestWheel framework in more detail, how it works, the user interface, and some of the key features and functionalities that make it unique. So without further ado, let's get started. So as you can see, right after a login, we land in the dashboard page. The TestWheel dashboard gives you a comprehensive overview of all your testing activity. It includes interactive charts, visual summaries that track your test execution, success failure rates, and trends over time, making it easier to monitor testing progress at a glance. The next tab we have over here is in relation to our collaborative testing. So TestWheel is designed for collaborative testing, which is crucial in teams. Within a single organization, you can have one admin and multiple testers and developers all working together on the same project. So everyone has their own role and access level, but they all contribute to the same projects, allowing for better test sharing, visibility, and teamwork. And let's move on to the next tab. The application page acts as the central hub for your testing activities in TestWheel. This is where all your test scenarios are listed, including application name, type, description, and environment. One of the standout features here is TestWheel's AI-augmented self-healing. This technology detects changes in the HTML attributes of your UI locators, meaning if a button or field gets modified in the UI, TestWheel will recognize it. And then at the end, the system will notify you about any changed controls, making it easy to maintain test accuracy. You have the ability to toggle this feature on and off by using this switch here. Now, if you go on to the next button here, the edit button, it gives you the option to edit an existing test scenario by clicking the pencil icon, which lets you update test environment or description as needed, as well as the test type from web application to REST API. Next button over is this green icon, and this is where you initiate a test from. Once you hover over or click, you'll be able to select the browser to initiate the test, and with that, your test will begin. And finally, we have this plug icon on the far right, which takes you to the record and playback tool, which is one of 3 methods for gathering UI test data in TestWheel, and we'll go deeper into the other 2 in just a bit. Okay. Let's head over to the documents page. The documents page is where all the files related to a given test scenario are stored and managed. From here, you can download pre-formatted Excel templates, which are designed to make the process of test creation as simple as possible. You'll see here authentication, UI properties, and user data, which we'll see in more detail in a second. Once you fill these templates out with your data, such as test steps, selectors, and input values, it's just a matter of uploading them back into the corresponding application. And after that, you're ready to test. Behind the scenes, TestWheel automatically generates Selenium automation scripts, so you don't need to write a single line of code. And this Excel-based workflow significantly lowers the barrier to entry for automation and makes test creation faster and more accessible, even for teams without deep technical expertise. So as the name suggests, the test results page is where you can view all of your previous test runs and their results. Each test result includes a full report of any defects or bugs captured during execution and a video recording of the test run. This makes it easy to review, debug, and track trends over time, especially in a collaborative or agile environments. Let's go ahead and open up one of these reports. You can see kind of what the report looks like. Take a look at this one. So you get one overarching report with a pass-fail result for the full workflow, and then also a step-by-step report as well for each individual step, along with corresponding screenshots. Let's jump on to application data. The application data page is designed to make test maintenance fast and convenient. So once a user has created and uploaded a set of documents or used the record and playback feature to record a series of steps, keeping those test steps and tests up to date is simple and efficient. All you need to do is select your test, hit view, and you'll be able to navigate through the test data that you just uploaded. You can make any necessary changes right here without needing to re-upload the entire file every time you make a small edit. And once you're done updating, just click the update button and your changes will be saved from there. All right. From there, you're ready to just run your test as usual from the application page. So this eliminates a lot of repetitive manual steps and makes ongoing test management much more scalable. All right. The next tab over, we have API test. So TestWheel offers 3 methods for API testing. It includes Swagger import, manual API test setup, as well as JWT authenticated APIs. And to get started, you just create an application like you would normally for functional testing. In this case, I already have one created. You'll see in the dropdown, API test demo. From the dropdown, you select the application you created and go ahead and start filling in the corresponding data. In this case, this is a JWT authenticated API. We can hit edit and see what our data looked like. You offer basic headers, authorization parameters, request body, and also test name, HTTP type, and target URL. Once all the data has been entered, you simply head back to the application page, navigate to that test, and run it. While that runs, we'll go ahead and move on to load test. So TestWheel includes built-in load testing powered by JMeter, allowing teams to evaluate system performance and responsiveness under heavy user load without needing an external tool. So unlike functional testing or API testing, the load testing in TestWheel has its own dedicated workflow with a separate initiation and results page. So to begin, you just navigate over to the load test page, select your application, enter the relevant details such as number of virtual users, ramp up time, duration, and target endpoints. So in this case, you'll see you get the test name, user count, loop count. You can go ahead and run the test from here. And once the test runs, you're given a full report in a zip file. So after the test is complete, the results are available on the load test results page, which includes an AppDex-based performance report, which we're looking at right now, along with key metrics like response times, throughput error, percentages, and more. This process makes it easy to identify performance bottlenecks early and validate system scalability all within the same unified platform. If you need more information regarding the report, TestWheel also offers a support page, which breaks down the graphics and charts that you'll see in your reports right here. Next, we have the manual test cases. So TestWheel supports manual testing and test automation in parallel, meaning you do not need to keep your manual test cases completely separate from TestWheel. Automation and manual testing can all be carried out within TestWheel. In this case, TestWheel is integrated with Azure DevOps in order to allow test migration and automate manual test cases without the hassle of having to convert them yourself. So TestWheel offers two methods for manual to automated test conversion. One is through migrating tests directly from Azure DevOps, and the second is through using TestWheel's pre-formatted Excel sheets. So in this case, if you download from this link here, you'll get the pre-formatted Excel sheet in which you would input your manual test data. Let's take a slightly more detailed look at the Excel documents that you would upload over to the application documents page. In this case, we're going to be looking at a set of tax to e-file test cases. The tax to e-file is an IRS authorized online tax filing service and has been using TestWheel for all its testing needs for several years now. This particular example walks through a simple test case with a basic login test and quick click through of a tax form. So with TestWheel's documents, first we have the authentication file. The authentication file contains 3 sheets: an about me, the data pool, and the test script data pool. The about me sheet provides instructions for how to fill in the data pool and test script data pool sheets. The data pool sheet hosts the URLs for each testing environment. For example, it would be dev, test, and production. In this case, we are only testing the production environment, so all the URLs are the same. And then we have the test script data pool sheet, which outlines the test scenario workflow. This sheet is key as it acts as the connector by linking the other 2 Excel files, which we'll be covering in a second. It does that through the columns like the property sheet name and the data table name. Okay. Next up, we have the UI property sheet. This file separates each test case into its own sheet and allows users to enter details on a case-by-case basis. Looking at the type, value, and action columns, it's straightforward. You provide the type of UI selector, the selector value, and then choose the corresponding action. TestWheel comes with a pre-built template that includes a drop-down of common selectors, including ID, name, class name, tag name, link text, partial link text, CSS selectors, and XPath, as well as action names. And if you need more options or descriptions regarding those action names, the full list is available on the TestWheel help page. Now, in traditional automation tools, you'd need to manually code each line or each action line by line. But with TestWheel's action library, this becomes a simple point and click experience. It dramatically reduces the time and effort it takes to build out tests and makes it much easier to manage as well. You can also speed up the process of collecting values and actions by using the TestWheel record and playback feature, which would capture the HTML selector data for you while you interact with the app, and then you can use that to auto-populate the UI properties file. Finally, we have the user data sheet. This sheet contains all the test data values associated with a specific test scenario. So using start and end tags, you can define which test cases to include from the authentication and UI property files. And the user data sheet enables test case reuse and makes your automation easily adaptable to different data sets or testing needs. Once the set of documents is completed, you simply return to the documents page, upload the documents to your respective application, and start the test. So we'll go ahead and do that right here. You hit upload, navigate to the appropriate folder, and upload in the order that you see the documents. So that is authentication, offer a short description, UI properties, and finally user data. Once the test documents are uploaded, you head back to the application page, find the application you just uploaded those documents for, and simply run your test. So while TestWheel is a cloud-based platform, we also offer a dedicated secure server environment with remote desktop access for organizations that require CAC. This setup allows for users to manually log in using their common access card, ensuring compliance with DoD and other federal security requirements, while still benefiting from TestWheel's automation capabilities. All right. So with that, thanks for joining us today. What we've shown you is just a glimpse of what TestWheel can do, from seamless test creation and execution to secure integrations and powerful analytics. So whether you've been looking for a fast-paced, agile environment test automation tool, or you're in a highly regulated federal space, TestWheel is built to bring speed, consistency, and clarity to your testing process without compromising on security or control. So if you're looking to reduce manual effort, catch bugs earlier, and deliver higher quality software faster, we'd love to continue the conversation. Feel free to reach out for a deeper technical walkthrough and a proof of concept, or to simply explore how TestWheel can support your team's specific needs.